Hello learners, I'm teacher James Kenyani. Today we are going to continue with the topic angle properties of a circle. And today I have two examples on the board which we are going to solve related to the concepts we learned earlier. So if you look at the first example, we have a circle there, and from the properties you get in the angle properties, there are some things you can highlight. We have, in the first question you asked, in the figure above, O is the center of the circle. So you are told to find the value of the obtuse angle AOB. An obtuse angle, you know, it's greater than 90 and less than 180. So we shall go straight to what we want to get. So if you look at the example, we have that obtuse angle AOB. And there is a concept highlighted there which you need to know. In the concept, we learned that the angle at the center is twice. If we have, for example, a chord AB, this angle at the center will be twice the angle at the circumference. And also there is another slight concept. You know what we call an isosceles triangle. In an isosceles triangle, two angles are equal. So if we go to our question, we shall first of all find C, the value at the circumference, the value of angle ACB. So to get that solution, we know we shall also first of all find angle ACB. Isn't it? And angle ACB is equal to BCO plus AOC. These two we shall get from the value, isn't it? We shall get from the value, from the properties of an isosceles triangle. So if we look at the first isosceles triangle, BOC, the value, this 20 degrees is equal to angle OCB or BCO. So the value here will be 20 degrees. And if you look at the other isosceles triangle, the value of OAB, OAC will be equal to the value of ACO. So it goes without saying that this angle here is 30 degrees. That is 30 degrees. So we shall actually, we should have now actually got the value of ACB. We now know BCO, which is 20 degrees. 20 degrees plus 30 degrees, which gives us 50 degrees. Now, after getting the value of the angle at the circumference, the value of the angle we are asked for, AOB, is equal to twice what? The angle at the circumference, twice ACB, twice angle ACB. And we know we have already got what? ACB, which has a value of 50 degrees. So this obtuse angle will be equal to 2 times 50 degrees, which gives us 100 degrees. So that is the value of that angle. It has emanated from the concept, if we have a chord, the angle at the center is twice the angle at the circumference, or the angle at the circumference is a half the angle at the center. So that is the value of that obtuse angle. So without much of ado, we go to the second question, which you see on the board. They are telling you the figure below shows a circle with the center O. A circle should always have a center. Find the values of angles A, there is B, there is C, and there is what? D. So if you look at the second question, it's slightly related to the first one. We have those two concepts, the angle at the center and the angle at the circumference. And you should also know properties of an isosceles triangle, which I think you learned earlier, even in your primary concept. So we go straight to the question. First of all, we analyze what we have there. From the diagram we have, we can get two isosceles triangles. One of them is PCQ and another one is PCS. Isn't it? So if you strike here, that dotted line, we have, there's an angle you can get there, which is SCP, isn't it? So we start with the A. Value of angle A is equal to CPS, angle CPS plus the value of angles CPQ. And if you look at our diagram, we don't really need to go much into calculating that. It's actually properties of angles in an isosceles triangle. Starting with CPS, knowing that the two angles in the isosceles triangle are equal, the value of this first angle will be 30 degrees. And the other one, similarly, given it's an isosceles triangle, the value of CPQ will be 40 degrees. That will give you the value of which angle? Of angle A, which is 70 degrees, which is actually 70 degrees. Now, we have B and C. We have B, value of angle B, C, and D. So to move quickly, we shall first of all get C, isn't it? When we get C, it is easy to get B, because the two angles add up to 360 degrees. So we go to C. From the first concept, which I said, when we are solving the first one, the angle at the center is twice the angle at the circumference. So the first angle we've got A is the angle at the circumference, and C is the angle at the center. So A is a half of C, isn't it? A is a half of C, and C is twice A. So C is equal to twice A. Twice A. From the concept we've got, the angle at the center is twice the angle at the circumference when they are subtended by which chord? QS. So having got A, twice A will be 2 times 70 degrees, which will give us 140 degrees. So you've already got C. Having got C, we know very well that we have now C and B. The relationship between B and C, they add up to 360 degrees. Isn't it? For many who don't know, B is also called a reflex angle. It has a value between 180 and 360 degrees. So B, since the two angles add up to 360, B will be equal to 360 degrees. Subtract 140 degrees, and quick computation there will give you what? 220 what? Degrees. You'd have got the value of angle B. We are remaining with one angle, and that is D. We are remaining with one angle. To get angle D, you'll create here a chord. A chord there. That chord is QS. And you'll use a property. The angle in the minor segment subtended by a chord in the minor segment, isn't it, added to the angle subtended by the same chord in the major segment, they'll give you a value of what? 180 degrees. So it shows that D, to get D, we have D is subtended by which chord? QS in the minor segment, and A is that angle subtended by the chord QS in the major segment. These two angles add up to 180 degrees. So if I know A, we got A earlier, D will be equal to 180 degrees, subtract 70 degrees, and it gives you 110 degrees. Those are the values of those angles, and the concepts we have highlighted are very important. Properties of angles in an isosceles triangle. Number 2, angle subtended by a chord at the center of the circle and at the circumference, their relationship. And lastly, the angle subtended by a chord in the minor segment and in the major segment. The two values of the angles should add up to 180 degrees. That is what gave us D. Yeah, so we've come to the end of our lesson, and I'll give you 2 exercises which you'll go to attempt. So the assignments, we have number 1. We are told in the figure below, O is the center of the circle. Show that the reflex angle POR is equal to twice PQR. PQR. In the second question, the question is, in the figure below, O is the center of the circle. LN and PM are all diameters. Show that LM is parallel to PN. Those will be the question for the assignment. So thank you for attending today's lesson. I hope to see you in the next coming lesson. Bye.